Once we have worked out the probabilities for individual events, we can look at the whole pattern of probabilities for all the possible outcomes of an experiment. And this gives us something called a probability distribution. So for example, going back to our dice, the possible outcomes, which we call x, are 1, 2, 3, 4, 5 and 6. And the probabilities of each one, of course, are 1/6, 1/6, 1/6 and 1/6. That is a probability distribution, how the probabilities are distributed over the individual events. Another experiment we can look at is the experiment of tossing 2 coins and counting how many heads we get. So in this case, if we toss 2 coins, we might get no heads, 1 head or 2 heads. And this time the probabilities, which we could work out with a tree diagram, would be 1/4, 1/2 and 1/4. And again, this is a probability distribution. And what we want to do is to look at how we can use these distributions to work out some other aspects of each experiment. The first thing we might notice is that in each case the probabilities add up to 1. A 6 plus a 6 plus a 6 and so on adds up to 1. 1/4 plus 1/2 plus 1/4 adds up to 1. This must be the case because one of the outcomes must happen. Something must happen, something is certain. And the way that we write this to express this fact is that the sum, which we write using the Greek capital sigma, that means you add up all the different probabilities, that must come to 1. So that's a check on whether we have a probability distribution. The probabilities themselves must be positive. You can't have a negative probability. You can't have a less than 0 chance of something happening. And the probabilities must add up to 1. Once we've got that, we can work out some other aspects of each experiment. And one interesting one is to work out the mean value of the experiment. And we do this by, again, adding up each possible outcome times the probability of that outcome. So let's see how that works for the dice. So for the dice, the mean, I have to take each possible outcome, multiply by the probability. So the first outcome was 1, multiplied by its probability. And the next outcome was 2 times a 6, 3 times a 6, and so on. And we end up with 6 times 1/6. Now that's an easy one to do because they're all 6. I've got 1 plus 2 plus 3 up to 6. 6. If I add those up, I get 21/6, which is 3.5. In other words, the average score on a dice is 3.5. If you rolled it 100 times, your total score would probably be around about 350, and the average, the mean, would be 3.5. For the coins, for the 2 coins, the mean, we multiply each x by its probability. So the first one is 0 times 1/4. And then we have 1 times its probability, which is 1/2. And then we have 2 times its probability of 1/4. So if I add those up, I've got 0 plus 1/2 plus another 1/2, and that comes to 1. And so the average number of heads when we roll 2 coins is 1 head.
Okay, Mary, so let's have a look at this one. So solve x plus 2x equals 12. So what do you think you do first?
Okay, well, I want x on its own, so I would put x equals 12 minus 2x.
Okay, so a lot of the time we want to get x by itself, but what we want to do first is get all of these x's together. So can you see anything we can do with this? Get all these together in one place.
Oh, okay, it's 3x, isn't it?
Yeah, absolutely.
So 3x equals 12. Oh, and so x equals 4.
Brilliant, spot on, well done.